Alright, boys and girls, welcome back to the drive-through for a little 2-8 action. Little sub thing here. We want our monies to grow like bunnies. Okay, just humor me here and do a little hypothetical. Let's say you got 2 bunnies, and you love your bunnies. So you decide that every month you're going to adopt 10 more bunnies. So after 1 month you have 12 bunnies, and after 2 months you have 22 bunnies. And after 3 months you have 32 bunnies, and hopefully you recognize this as an arithmetic growth, a linear growth, an arithmetic pattern, if you will, whatever. The slope is 10, the y-intercept is 2, so this would be y equals 10, x plus 2, or if the way our book is writing it, f of n is 10, n plus 2. So, okay, just out of curiosity, 10 months later, how many bunnies would we have? 10 times 10 is 100. 100 plus 2 is 102 bunnies. Not bad. Not bad. Okay? Now, in the second hypothetical, let's say we also start with 2 bunnies. But our bunnies are going to grow by 200%. Okay, which means we're going to double every month. Okay, because that's what bunnies do in real life. They just do bunny things, and all of a sudden there's 2 bunnies, and they do these bunny things, and then you look down and they got 2 more bunnies. Okay, so after 1 month you would have 4 bunnies, and after 2 months you would have 8 bunnies. And after 3 months, you would have 16 bunnies. And a lot of times students don't look over the long haul, and they look at this and they think, oh, I'd rather have the adopt-a-bunny. I get more bunnies for my buck. But that's just simply not true. If you have some patience, if you let your money grow like bunny, it will pay off. Okay, so let's check out 10 months later. Okay? First, in order to figure that out, we would need to know the equation. Well, remember, this equation is y equals b times the rate to the n power. Okay, so this would be, or remember, that could be f of n if that's the way you want to write it. So f of n, where did we start? What's our y-intercept, our b? It's 2. Okay, what is our rate? It's 2. So 2 times 2 to the n. So what is 2 to the 10th power? Well, I don't know that, luckily, because I have a life. 2 to the 10th power. I also don't know how to turn a calculator on. Oh, look, there it is. 2 to the 10th power is 1,024 times 2. And you get 2,048 bunnies. Now that's what I'm talking about. That's how exponential growth can get things big fast. So now let's get down to business. I want you to pause the video and read the situation that you have in front of you. Okay, so hopefully you understand that we have 2 companies. We have Calcularama, sorry, you can thank the ViewSonic for that. And then you have Computer Fest. And I'm using the end of the words because annoyingly this book made them both start with C, and so it's hard for me to keep track. In fact, you know, I think I'm going to need more room. So give me a sec. Okay. So Calcularama has $5 million of income to start. So, 5 million. Computer Fest has $2 million to start. Okay. Calcularama is going to increase their income by $500,000 per year. So plus 500,000, that's $500,000. So the next year they'll have 5,500,000 in income after 1 year. Okay, where Computer Fest is going to increase its income by 15%. Well, what that means is you're going to multiply by 115%. Keep in mind, if you multiplied something by 100%, it would not change at all. It would be multiplying it by 1. So if you multiply it by 115%, keep in mind that's a multiply sign, it's a dot. Okay, if you multiply by 115%, it's going to get 15% bigger. So let's go 2 million times 115% is 1.15. It's easy to mess that up. Let's see how much we have. They have 2,300,000 after 1 year. So once again, the average student would be like, oh, I'd rather invest in Calculorama. Okay, look, after a year, they've got even faster growth, and they already had more to begin with. So I want Calculorama. But before we get into anything more specific, let's start talking about their formulas. So hopefully you're getting better at predicting the formula. This is going up by 500,000 every time. That means it is linear growth. The linear model is f of n equals mx plus b, or in this case mn plus b because it's a function of n. So f of n, well, what's the slope in this problem? The slope is the amount that it's going up by every time. So that is 500,000. N plus, where did it start? 5 million. Okay? Where the fest, hopefully I have enough room. Let me just draw a little divider here. Fest is geometric growth. If you remember, geometric growth, or exponential growth, I should say, geometric patterns. Well, that is g of n, I'm just writing it as a different function, g, is equal to b times r to the n power. So where do we start? We started at 2 million. Times our rate is 1.15, 115% to the n power. Okay, so we're going to need to kind of remember these. This is the Rama equation or function, and that is the Fest function. So compare the two companies. How are the representations for the net incomes of the two companies similar? In both cases, the companies are increasing. How do they differ? Well, Rama is increasing linearly, where Fest is increasing exponentially. What relationships are highlighted in each representation? I don't even know what that means, so I'm skipping it. If both companies were able to meet their net income growth goals, which company would you choose to invest in? Well, if you watched the intro, I am investing in Fest, because I am all for exponential growth. Even the smallest amount of exponential growth will almost always dominate linear growth in the end. Okay? When, if ever, would your projections suggest that the two companies... Let me rearrange this window real quick. Alright, I'm super pumped to show you guys this. We're going to finally use our graphing calculator in a video. The first company, the equation was 500,000 x plus 5 million. Okay? The second company. The second company was, let's see, let me scroll back real quick. Let's see, it was B times R to the N. It was 200,000 times 1.15 to the N. 2 million, where we started, times 1.15 to the X power. All right, let's look at the table. So the graph isn't going to show you anything. Now, if we zoom, so how about we go zoom out again. It's just too big of a graph. These are too big of numbers. But let's look at the table. The table is telling us something. Okay, so I had to do something real quick. So if these things happen, I had to highlight this equal sign. It wasn't highlighted, so it wasn't showing up on our table. When I highlighted it, now when I go back to the table, now I can see the thing to compare them. Now you need to learn how to read this table. This 5E6 is actually scientific notation. What that means is 5 times 10 to the 6th power, which means 5 million. Hopefully that makes more sense. Okay, so look, Y1 represents oh dear. Y1 represents Rama, Y2 represents Fest. Notice, Rama starts out significantly above Fest. But as we get down, Rama more than Fest. So let's scroll down in our table. Rama more than Fest, Rama more than Fest, Rama more than Fest. Oh, after 12 years, it's getting really close. Okay, now they're both worth about $10 million, but watch what happens to Fest. If you just go to 20 years, now Rama is worth 1.5, that's $15 million, and Fest is worth $32 million. So if you just would wait 20 years, your investment would be worth so much more, literally more than twice as much, because of the exponential growth. And that's the thing that I'm really passionate about you guys learning from this section. Okay, so the rest of this is pretty clear. How would you find this? You'd use a table or compare their graphs. Will they ever have the same net income again? Not after that, because you're going to have one graph is growing like this, and the other graph is growing like this. And then after that point, the purple graph is going to be worth more. Oh gosh. The purple graph is going to be worth more forever. And this is the point that you have to be patient for. This is the point where you start to make that money. Okay? Since we are creating models for these companies, we can choose to have a discrete model or a continuous model. What are the advantages? Well, in a discrete model, I think you could only maybe cash your money out at the end of every single year, whereas in a continuous model, you could cash your money out at any single minute of any single day that the market was open. So, I don't know. I'd probably rather have a continuous model because this is the Synovation Lab and we like our flexibility. If you are made it to the end of the video, I'm so appreciative of your time. This is the longest video of the year, but it might be the most important video we watched so far. How to make your money work for you. Boom!